Hello, welcome everybody after the break. We've just had a talk about logs, and now the last talk of the day. So we will welcome Maciej Raszplewicz with his talk. Hello, welcome Maciej.
Hi everybody. Hi.
Yeah. So your talk will be about infrastructure as code and about testing it, in fact. So,
yes, that's correct.
Yeah, I've seen many different generations of infra as code, and I'm really interested to see what particular technologies you are going to talk and actually how to test it. So without further ado from my side, only one request to our audience. So please, if you have any questions, please ask them in chat, in inventory. And now I would like to give the stage to Maciej. So please, the stage is yours.
Hi everybody. I will talk about testing in infrastructure as code and probably why Terraform may not be the best infrastructure as code tool. There are other options. So maybe we shouldn't write any tests. If we don't do that, they will not fail, but maybe it's better to have some. Something about me. I have over 15 years of experience in IT. I worked in many projects, had many roles, and can write code in multiple programming languages, Java, C#, Golang, you name it. I have built quite big distributed systems for telecommunications and insurance company, and recently I'm doing I have my own startup called DevOps, and we are doing infrastructure as code, and I'm doing infrastructure as code for about 4 years or a little bit more now, so I have some experience in this area. The presentation will be about tests, so I will start briefly and tell something about tests. Then I will show you TeraTest, which is a common tool to test Terraform. Then I will go to our mini framework, which we have created to test infrastructure as code. Then I will tell something about other infrastructure as code tools, and maybe something about future or my predictions. So first of all, why automated tests? For me, these are the three most important factors. First of all, we want to avoid regression problems. So we want our code to work even after some changes. So we will not have to test all the things manually all the time, but only we can test everything automatically, and then we are sure that our code still works after some minor changes. Then faster development. Maybe some people disagree, but I think if we have automated tests, we can develop faster. I will tell something about it on the next slide. And of course, better code quality. There are more factors. If you have some other factors, not there are multiple. And there is an old concept of test pyramid. The concept is that you should have UI or service tests, integration tests, service. They are sometimes called integration, sometimes service, and unit tests. And the pyramid says that you should have quite a big number of unit tests, less integration or service tests, and less UI tests. Why? Because when we are going up through the pyramid, tests are becoming more fragile and slower. So, for example, UI tests depend on the browser, the client, machine, and something like that. Service or integration tests depends on network, on code that is not necessarily ours. It could change, and unit tests test only our code and are very, very, very fast. So I think we should have quite a big number of unit tests. And one more thing, if they are really fast and they test only our code, there is no. This is the only the fastest way to test our code, to check if it actually works, if there are no problems in our code. So this is also the fastest feedback loop. So it means when I write some code and want to check if it works, nothing is as fast as unit test. The problem we will solve today, the example problem, is bucket S3 bucket module. Imagine that you have requirements to implement S3 bucket module in your company. It has to go through some naming conventions. So you have to write code which will name all the buckets in a specific way. I will show it soon. So there are things like your company name, your environment application. Why we should have naming conventions? There are multiple reasons, but one thing to remember: S3 buckets names are global, so you don't want to have conflicts with other S3 users. Okay, so I will show you TeraTest now, and first of all, I will show, of course, how is the module implemented. Okay, so let's start with the module code. It's very, very simple. Wait a moment. I will hide this one. Okay, so the Terraform module is very simple. We've got S3 bucket resource and some rules in local variables. Why rules here? Because we wanted this naming convention to be present here. We have company name dash env name dash app name dash bucket purpose. Bucket purpose is pictures or documents or something like that. Why we have this bucket in our company? Then there is problem that the maximum length of our S3 bucket is 63 characters. So if it is only 63 characters, then if somebody need to have longer names of all those things, then our code should work. So what can we do? If it's more than 63 characters, we are just doing checksum of the requested bucket names and substring it. And if it is not 63 characters, it is less, then just do the request, just have the requested bucket name. So this is our Terraform module. Maybe it's not very complicated, but we can see already that the code here is maybe not the most readable. And then how to test it? We can use TeraTest. It is quite common in Terraform world. I will show it. now in Golang, the different idea for Go. Okay, so we've got a test written in Golang in TeraTest. The test code is divided into two pieces. There is a data structure containing all the data we need for test. It's called data-driven or table-driven tests. I advise you to do this kind of tests. There you can test multiple conditions in one test, so you have only just here. This is the short name. This is the long name, and then we want to run all the tests here. With TeraTest, we've got some convenient methods like copying Terraform folder to temp, like passing all the variables to Terraform, like cleaning up. This is the third Golang keyword. It will take place after the test. And here init and apply. And also we've got assertions. We can check if our name of our bucket is equals the expected name. So if it is this one or this one. So let's test it. Let's run the code. I have to wait a moment, not for long. It is already running. Here we can see that. What is the problem with this test? First of all, we depend on the cloud. So it can fail in some circumstances. There is it is possible that it will fail. For example, someone else will run this test and have the same bucket name. Another thing is that I'm talking while it is taking place, so it's quite a long time to do it. It was over 1 minute to run the test, so it's not the best option. Why? Because it is an integration test. It's not a unit test. Unit tests are fast and don't depend on anything external. Here we've got integration test, which is long and maybe not very fragile, but quite, but it can fail. Okay, so let's move back to the presentation. So another thing about TeraTest and testing this way is you have to write the test in Golang. I have learned Golang about 2 years ago, and before that I wanted to have a tool in programming language that I know. I feel well writing code in this programming language. So this is Java or Groovy or something from Java world. And we decided to write our own tool. I will show you it soon. One more thing to mention: Terraform itself is experimenting with some solution of testing. There is a link here, but it is still experimental. So maybe they will invest more time in that and do something good. But I read that it's also integration test, not the unit test. Okay, so how our mini framework works. It is based on Spock. It is a common testing framework for Java world. We've got experience writing tests in Spock, and one more thing, it is you write your tests in Groovy. So this is kind of dynamic language, and you can write tests in convenient way with Groovy. I will show you that. And In our mini framework, it is we are able to test Terraform or AWS CDK, and I will tell you more about CDK later. And now show you again how we test Terraform. Okay. So the same module, but we are this time testing in using our mini framework. We've got integration tests here, and there is a S3 module test. How it works? Actually, it's very simple. It uses Terraform executable, and you have to have it installed on your computer. So it just executes Terraform underneath and run Spock tests. And here you have to extend this Terraform integration test base class. The code is on GitHub, and you are free to get it, to write it if you want to have it in another language. So if you want, just take the code and use it. Okay, so if you extend the base Terraform integration class, then you have to declare Terraform variables and tell Spock what to do. So deploy Terraform module. This is the module path and the variables. Then check if the bucket exists. We are using just normal AWS SDK for Java to do the assertion here, and then clean up, destroying the bucket using Terraform destroy. Here you can see that again we are using data-driven tests. It's good practice to test everything using data-driven tests. We have two tests in one code. So okay, so let's run it and check if it works. Again, I have to wait. Why? Because it's an integration test, and I am doing it against the real cloud. So waiting and waiting and waiting, about, again here, 1 minute or two. What we can do to have it faster, we can use local stack. So our mini framework already supports local stack. I will not show it now, but you can use it with our mini framework. As far as I know, TeraTest doesn't support local stack yet. You can use it, but the assertions are not working. They have GitHub issue. There's an issue in GitHub, and I'm looking for time to time, and they haven't implemented it yet. So we can use local stack with our own assertions, or use our mini framework and just use local stack or the real cloud. Here we are using the real cloud. We can see that a single test took about 50 seconds. So with S3, this fast. If you want to try testing RDS or some other AWS resource, it will be much slower. Okay, let's wait a minute. Okay, so more than 1.5 minutes to run the test. So is it good? I don't think so. It should be better. The experience is not that bad, not that good. So what can we do? We thought that Terraform is one of the only options when you think about infrastructure as code. But then we did some research, and it turns out that there are frameworks where you can use general purpose programming language and write your infrastructure as code in normal, really code, and even in Java. So again, I will show you how to do that. It is one of frameworks is called AWS CDK. So I will show you how to write a simple S3 module in AWS CDK, and then show you how you can test it, and you can test it using integration and unit test, because it's a general purpose programming language. So first of all, I want to show you what's the difference between AWS CDK and AWS SDK. I have to switch branch to do that. Wait a moment. Check out AWS SDK branch. Okay. So I have code here, which is creating an S3 bucket in using AWS SDK. So how to create that? We can use S3 client. We have to check if the bucket exists. We have to, if it does not exist, we have to create that. If it exists, we have to update it. And what if we want to delete it? We have to again create some code to delete the bucket. So this is imperative way. We are using AWS SDK again as AWS SDK to create a S3 bucket. Is it infrastructure as code? Yes, probably, but it's not an infrastructure as code framework. So what's the difference between SDK and CDK? I will show it now. Again, change the branch. Okay, so in CDK, you have to write the code like this. So you are creating the bucket. This is declarative, and the framework takes care of going through all the API calls. Actually, it is using CloudFormation underneath, so it is generating CloudFormation template and calling CloudFormation service to create all the things you want. And how can we remove the resource from the cloud? Just remove the code, execute it again, and it will be the S3 bucket will be removed. So this is as simple as that. Okay. So I hope you got the idea how the CDK is different than SDK. It's more like Terraform, but you write it in Java, TypeScript, JavaScript, or Python, as I remember. There are a few programming languages you can use, and do it declaratively, like in Terraform. Okay, so how to test that? Again, our mini framework supports this kind of test. You just have to extend CDK integration test, and other things are almost the same as you could see in Terraform example. That's deploy. That's the CDK construct. Construct is a module, kind of module in CDK. It's part of code, reusable part of code in CDK. So this is similar to Terraform module. So we're deploying we are checking using this exactly the same method if the 3 bucket exists, and we are destroying each in cleanup method. What's the difference of this code and Terraform? We are not checking all the cases here. Why should we check all the cases if we can do it in unit tests? We can check the actual naming convention in unit tests, but here just check if the module works, and not all. We don't checking all the cases here. Just one is enough, and just one integration test is enough. So let's run the integration test. Again, this is an integration test, so we have to wait for that about probably 15 seconds, more or less. If something goes wrong, it will fail again because we are using the real cloud. Okay, we have logs here from the CDK. So okay, it is created, and again, in this in our framework we are executing real CDK binary to execute all the tests. It was more than 1 minute. You can see that here. We are executing the real CDK binary. You can't execute CDK without its binary. So I don't like it in this framework, but that's how it works. You have to use CDK library binary to execute it. So we are actually launching one JVM from another to execute CDK. They are using some bridge to JavaScript. That's how they do the multi-language support in CDK. So that's probably why you need to use the CDK binary. Okay, we can see that it works, but again, it's not a unit test. But here, our code is in Java, so just do the unit test. We can test our naming convention here using normal unit test, and is it slow? No, it's a little bit more than 100 milliseconds, so the other run will be probably much shorter. And we can change something in our naming convention. The naming convention is implemented as a normal Java method here. So we'll change something in our naming convention, and I'll show that our test will fail here. So the naming convention is wrong, and the feedback loop is really fast. Okay, it failed. The difference is here. We've got really fast feedback loop because we are using general purpose programming language and unit tests. Okay. Going back to the presentation, comparing Terraform and CDK, these tools are completely different. In Terraform, you've got limited language, which is declarative. It's HashiCorp configuration language, but it's not as powerful as normal general purpose programming languages like Java. Using AWS CDK, you can write in normal languages, you can use libraries, different libraries, you can do just anything you think you can do with normal code. So it's more powerful, it's really convenient to write this code when you are when you have developer background. Maybe Terraform is easier to learn for sysadmins, but I really encourage you to at least try Cloud Development Kit CDK, because there are a lot of benefits over Terraform, which for me are very, very important. The testing is one of killer features. You cannot achieve that in Terraform. It's impossible. With CDK, you can do that, and that's okay. Okay, so I will tell you something about other infrastructure as code tools also. There are a few of them. You can, first of all, you can use CloudFormation or similar tools from other vendors like ARM, I think, in Azure, or other things in other clouds. So these are native cloud tools. There is, of course, Terraform. There is also CDK. The problem is that it supports only AWS, but there is also an experimental project, maybe not experimental, maybe something more now, which is called Terraform CDK, which is CDK on top of Terraform. And with this tool, you will be able to execute code and use Terraform in normal general purpose programming languages like Java. So this will be like eating the cake and having it. The problem with both of them, the CDK and Terraform, and Terraform CDK and CDK, is that you have to execute external binary. It's impossible to execute it directly from code. So the tests I showed you recently were actually some kind of hacking the problem and executing the binary and not running directly from the code. And there is also one infrastructure as code tool which I also like. I did one project using that. It's called Pulumi, but there is no Java support yet. So for me, CDK is better. I am more productive using CDK, but Pulumi is also very good. You can use JavaScript or TypeScript or other or C# or other programming languages in Pulumi. So it is quite similar to CDK, but independent, supports multiple clouds and other languages than Java. Maybe they will add support to Java soon, I hope. So the future of IaaS, infrastructure as code. For me, the future is in this kind of tools like CDK or Pulumi, because developers can write code faster, better quality code in this kind of tools, and you can be really productive, have reusable code, and that's why I think this is the future. And there are some problems with these tools. I already told you about executing from inside the programming language. So you can, for example, execute multiple stacks from a single place in code. It's impossible without executing external binary in CDK. It was impossible in Pulumi, and they fixed it recently. So in Pulumi, you can execute it from your code. Okay, I think that's all what I wanted to say. So let's go back to studio. Maybe there are some questions.